Ladies and gentlemen, please welcome President and CEO, Dave Ittycheria.
Good morning. How's everyone doing? Good. Good to know that coffee's working. Everyone's alive, awake. Well, welcome to MongoDB World right here in New York City. This is our 6th annual conference, and it's truly an event to celebrate the community. Now, most conferences, focus a lot on hype and glam because they don't have that much content to share. But our conferences are truly learning conferences. Most people who come here come to learn about the technology and the products and capabilities that we have. A lot of people come here to meet the engineers who actually wrote the code and built the products. Many of you come to hear from other people in the community, what people are doing, what transformative things you're doing with MongoDB in your own business. And last but not least, you come here to hear about the new products and services that we're going to announce. And boy, do we have a chock full of announcements today. So welcome to New York. We're really happy to have you. And there's been a bunch of events that happened yesterday. We had a number of sessions that were literally sold out. You couldn't get in the door. So we're going to run those sessions today and tomorrow. We encourage you to try and attend as many sessions as you can. Now, our community is so large, it's really hard to have one conference where we can invite everyone. So a few years ago, we expanded the conference to London and other parts of the world just because the community was so big. And it still wasn't enough. This time last year to today, we've had over 70,000 people attend over 100 events around the world. That gives you a sense of the magnitude and the power of MongoDB. One of the places that's a little dear to my heart is India. I was actually born there, even though I'm a US citizen now, and I call the US my home. Obviously, I have a lot of affinity to India. The government body there called the Central Board for Secondary Education, which is the standards group that defines the curriculum for all students up to 12th standard. They basically define what courses students have to take, is really focused on making sure students are prepared for the future. They're really focused on making sure that these students are well equipped to compete in the information age. So they're spending a lot of time on programming technologies and even computer science in high school. And in fact, this past year, CBSE mandated that every high school student in India would get an overview course on MongoDB. That speaks to the power of MongoDB around the world. So MongoDB has increasingly become the database of choice for almost everyone. In fact, in the past year, we've now exceeded over 70 million downloads of our software. Now, to put that number in perspective, there are supposed to be between 20 to 25 million developers in the world today. So essentially, developers downloading our software at least 3 times. That gives you a sense in terms of how popular MongoDB is. And to validate that, there's a site called DB Engines. DB Engines ranks the most popular databases in the world. And MongoDB is the 5th most popular database in the world today. Now, normally, I wouldn't really crow about being number 5 at anything. But when you look at that list, the top 4 have been around for at least 25 years, if not 40 years. That gives you a sense of how quickly and how popular MongoDB is becoming. It is truly becoming a global movement. But I'm not done. Stack Overflow runs the most comprehensive survey of developers on a worldwide basis. In fact, in the last survey, 90,000 developers responded to the survey across from over 180 countries. So it's truly a global survey. And they asked lots of questions around what technologies do you use up and down the stack, what technologies do you plan to use, and oh, by the way, what technologies do you really want to use? And for the 3rd year in a row, MongoDB is the most wanted database by developers on a worldwide basis. That speaks volumes about where we're going and the value MongoDB is providing. And this demand is driving customer adoption. In the past year, we've exceeded, in fact, we announced in our Q1 earnings call, we have over 14,000 customers. And that number has grown by nearly 5x in literally a little over 2 years. So these customers range from some of the largest and most sophisticated companies in the world, large banks, telecom companies, media companies, tech companies, and also cutting-edge startups who are doing groundbreaking things and trying to disrupt giants or break into new businesses. So we feel really good about the adoption of MongoDB across this wide variety of customers all around the world. Now, I may be preaching to the choir when I say that we are in the early stages of one of the largest platform shifts in computing history, and that's the move to the cloud. And many of you are on this journey today. Some of you moving very quickly and going all in, and others are moving more cautiously because you might be working in a regulated industry where there's lots of rules and approvals that you need to do before you can move workloads to the cloud. Well, we saw this, and we introduced Atlas 3 years ago, right here at this conference in New York. And Atlas started in 4 regions at AWS in 2016. Today, it's now available in 64 regions around the world. It runs across Amazon, Google, and Microsoft. And by virtue of running across the 3 major cloud providers, it is the most widely available global cloud database in the world. And developers are really embracing Atlas. We introduced this notion of a free tier where you can basically sign up for a free account in 2017. In the last 2 years, the number of people signing for free tier accounts has exploded. In the last year alone, it's grown up by 15x. And to give you a sense of Atlas in terms of the workloads running on there, we now are seeing many, many mission-critical workloads. Large banks are moving workloads to Atlas. Telecom companies, government institutions are moving workloads to Atlas, so it's not just for the startups. Big companies are doing so as well. And to give you a sense of what's going on, there are roughly about 112 billion queries per day going on in Atlas. That gives you a sense, again, of the kind of activity on that cloud platform. So Forrester noticed this, and they just recently introduced their latest wave report on the database as a service market. And we actually were ranked as a leader, which we were very pleased about because this is really the 3rd year we're introduced to service. And we scored top marks on 12 of those categories. Now, what's interesting is when you zoom into the leader segment, you basically see that we're surrounded by mega giants. And I'm pleased to note that Amazon, Microsoft, and Google are here with us today. We sent an invitation to Oracle, but for some reason they couldn't make it. And Amazon, Google, and Microsoft actually are partners. And partners are really important to our strategy. In fact, we have partners who help us extend our reach because this market is so big and we can't be everywhere. We have customers all around the world. They allow us to reach customers. They allow us to help customers with their digital transformation initiatives. They allow customers to modernize their legacy infrastructure. And they help customers move to the cloud. And these partners include people like Accenture and Infosys and Capgemini, IBM, AppDynamics, Datadog, New Relic, and a whole bunch of other companies who are using MongoDB and helping people use MongoDB to transform their business. And I'm pleased to note that we have a lot of these partners who have really helped support our conference, and these are our sponsors. In fact, IBM is our premier sponsor, and you can actually use IBM Community in the, MongoDB Community in the IBM Cloud today. So one of the questions I get is, what does the future hold for MongoDB? People are always saying, where are you taking this company? Where's the products going? And so on and so forth. And it's very hard in an industry that's moving so quickly and the pace of change is accelerating to sit here with certainty and say, this is what's going to happen, not just today and tomorrow, but 5 years from now, and even 10 years from now. So rather than trying to predict what will change, we think about what won't change. What are the eternal truths that will still remain the same 5 years from now and 10 years from now? And the question we ask ourselves is, what will developers want? And we believe that developers will want to be highly productive and move quickly. I cannot imagine developers saying to us, you know what, slow down, I'm just working way too hard. They'll want to scale easily on agile infrastructure. In fact, they want the infrastructure to move out of the way so they can get their work done. They want to work with all kinds of big data and all varieties of data easily, no matter where it sits. they don't want to be locked into any one compute environment because their business needs may change day in and day out. And last but not least, the performance and stability requirements that they have only increase, or end users' requirements for performance stability only increase. So when you have conviction that these things will remain the same or be important, not just today or tomorrow, but 5 years from now and 10 years from now, it gives you conviction on what products to build and how to serve this community. Then the question we ask ourselves is, how do we fund this? Do we have the resources to fund this endeavor? Well, as you know, we've had a very good year at MongoDB. And we're very grateful for all the support we received. And that success allows us to invest in the products, in our R&D efforts, and in rolling out new capabilities. In fact, this year alone, by the end of this year, we will have invested over $400 million in R&D as a company. There's not many companies that can say that. And to speak to you about where we're going as a company, where we're taking our products, and the new cool stuff we're going to announce today, please join me in welcoming Elliot Horowitz, our CTO and co-founder, to the stage.
Searching for the right way to start a keynote, always a little tricky. Not ambitious enough, could come off a little boring. Too ambitious, also a turnoff. So searching for exactly the right way takes time and energy. I started searching by searching through all of our release notes, looking for that tidbit that might get people really excited. Then started searching by talking to friends and coworkers and searching their brains for how to start this off. Nothing yet. Then started searching by looking at old tech keynotes, trying to search through those for some inspiration. The more I searched, the more I realized that sometimes searching is the answer. Sometimes when you're searching, search is actually what you're looking for. Turns out that a lot of other people are searching for things too. In fact, most of the applications everyone here is building probably needs some form of search. And today, adding search to your application is kind of annoying. So we're going to start off this morning by talking about how MongoDB is going to make search really, really easy. Today, what you have to do is something like this. You've got your data in MongoDB. You've got to run some other third-party application. You've got to manage some sort of synchronization, keeping that data in multiple places. You've got to keep this all up, scale it, figure out how to make this work. And of course, what's actually happening is all that data is going into Lucene, the most popular open source search engine. So we thought we'd make this a lot simpler. We thought, let's just integrate MongoDB directly with Lucene. And let's go further. Let's make text search natively built into MongoDB. So you don't need a separate driver. You don't need separate tools. It'll just work. Let's go further. Let's put all of this inside of MongoDB Atlas so you don't have to think about managing it, running it, keeping it up, what goes wrong if it breaks, backing it up, or anything else. You can configure it in the Atlas UI, run a query directly through any MongoDB driver or tool or the shell, and set it up in a matter of minutes. And to show you just how easy it is to do, and to get this keynote really started, I'd like to invite to the stage Karen.
Hey, look, Ma, I made it. Hey, look, Ma, I made it. Everything's coming up.
Thank you, Elliot. With MongoDB's new full-text search indexes, you can now easily integrate sophisticated search capabilities into your application. Let me show you by implementing a simple full-text search on some sample data that Atlas provides. Here inside the Collections tab on your Atlas UI, you can see my movies collection in my sample Inflix database. This collection consists of over 23,000 movie documents, each with different fields of varied data types, such as title, plot, and cast. Well, I want to build a search engine that's going to look for a movie based on a topic. So to do this, I'm going to use full text search to look for specific words and phrases in my full plot field. The first thing I need to do is create a full text search index. We've made creating an FTX index as easy as possible. By default, we dynamically map every field in your collection. Mapping is simply how we define how the fields in our documents are indexed and stored. If a field's value looks like a string, then we'll treat it as a full text field. And because it's dynamic, well, this suits MongoDB's flexible data model perfectly. Over time, as you add new data to your collection and your schema evolves, well, we can accommodate those changes in your schema and add that new data to your search index as well. And if you need to map explicitly, say if you only wanted to index on certain fields, or if you wanted to change your analyzer to French, you can set that up here as well. But for now, I'm just going to accept the default settings and click Create. Now, to show you an aggregation pipeline that makes use of this index, let me switch over to Compass, our graphical user interface for MongoDB developers. Here, inside of Compass's aggregation pipeline builder, you see that the first stage uses the search beta operator to query for werewolves and vampires in our full plot field. Next, we'll use $project to get back just the fields we're looking to use. This, in combination with the meta projection operator, we've built out an entire query to return movie documents along with their scores and highlights. This score signifies how well this movie document's full plot matches the search terms werewolves and vampires above. And if you see here on the right preview panel, the search beta operator returns these documents to us with a score in descending order, thereby providing you the best matches first. Exporting pipeline to language will bring us this aggregation pipeline in code. And it's this small snippet of code that powers our movie search engine. So let's see what this looks like in the live application. Here, let's look for that movie about werewolves and vampires. And as you can see here, the movies are returned to us with the highest scores first, therefore the most relevant plot fields first. You'll also see the highlighted snippets in the plot field that was surfaced by the meta operator. You might notice that werewolves is highlighted as well as vampires. But what about and? Well, we've applied the standard Lucene English analyzer to our default FTS index in order to remove such common stop words such as and or the and improve the accuracy of our search. Now, this is a very basic use case of a full text search index, but this same index that I created enables so many more powerful search features. In this similar UI, for instance, I've enabled type ahead to help our users find what they're looking for faster. So Star Wars, Return of the Jedi. Or, let's say I want to look for a movie about superheroes, and I am quite nervous, so there's a typo there, of course, but it still works, and that's fuzzy matching in action. Of course, you combine any of these features that I've just shown you with many others in different ways to let you build out even more fine-grained searches. In MongoDB, we know that data is important, and having the ability to look for exactly what you want, even if you don't quite know what it is or how to spell it, is also important. As you've just seen, in not a lot of time, you can create a full text search index on your database to unleash awesome new search capabilities. And the best part is that you don't have to set up any additional systems or infrastructure to do it. In Atlas, starting with 4.2, all of this comes with a simple click of a button. Thank you. Thank you, Elliot.
It's really that simple. To learn more, start searching. Ben and Doug, the product manager and engineering director behind Full Text Search, are giving a talk later this afternoon. So Full Text Search fully integrated directly in Atlas, directly in the MongoDB query language, nothing to manage. And in Atlas, it's also no additional cost. You have to pay for the disk space, but that's it. Same Atlas, same everything. Easy to set up, do it in a matter of minutes, and you have the full power of Lucene. So when can you start searching? So the public beta is available this morning. You can go and start searching right after this keynote. You're not going to want to miss the next hour. In 2007, Dwight Merriman and I were going to go build an app. Spent a few days, started designing it. We were getting pretty excited. We pretty quickly realized that data was going to be our biggest problem. In the decade prior, between Dwight and myself, we created a dozen custom data stores to work around problems with databases. And we pretty quickly realized that the same thing would happen here. So we started designing the database that we needed for our app, and we started designing the database that we always wanted. So the characteristics of that database, first, it was a document database. Right? The kinds of data we were storing was complex, polymorphic, it was big. We needed to store that kind of information. So we wanted a document database. And at the time, XML was the most popular language for defining documents. But we didn't like XML. And I don't think a lot of other developers like XML either. So we chose JSON. We were like, we want a JSON database. But we want that. We want a JSON database. We want to combine it with the best features of relational databases: ad hoc querying and indexes. Then we wanted to harness the power of distributed systems. Companies like Google and Yahoo had great engineering teams building really powerful systems on top of these principles. But outside of those companies, no one could take advantage of it. And we wanted developers everywhere to be able to use the power of distributed systems. And third, we wanted it to be open, so that anyone could use it on any platform, on any hardware, wherever they wanted to build software. So we started talking to our friends. Turns out, a lot of them had very similar problems that we had and wanted a similar kind of a database. And the common theme was that the kinds of applications people were building were starting to change. We were building a modern application, and so was everyone else. So what is a modern application? First and foremost, making your developers productive is paramount. Hardware and software is much cheaper than developers, and getting your developers to be able to get features and products out the door faster is the difference between success and failure. You need your infrastructure to work for you. You don't know where you're going to deploy. You don't know what's going to happen. You want your infrastructure to scale, to manage itself, so you don't have to think about it. You've got a lot of data. We're not better at generating data now than we were before, but hard drives have gotten so cheap that we can now store everything. Why delete anything? 20 years ago, when you were taking pictures on a digital camera, it really mattered how many you stored. Now, when I look at other people's phones and scroll through their photos, they never delete anything. They just keep every picture on their phone forever. Hard drives are cheap. And the longer you store data, the more polymorphic it comes. You have data from different years, from different types of sensors, from everywhere, and it's always changing. Let's talk about your users. Your users are like me, impatient and demanding. Your users want all their data in real time, right now, on any device, anywhere in the world. And if you don't give it to them, they're going to go away. So Dwight and I started focusing just on MongoDB. We started focusing on building the database that we always wanted, and the database that is the best database for building modern applications. And it's built around three core principles: the document model, distributed systems, and the fact that you can run it absolutely anywhere. My goal is to work making data easy for developers wherever they are. And this morning, we're going to talk about how we're making data easy to work with for developers in three core ways. The first is in the core database. The second is how to operationalize it. And the third is about how we solve problems outside of the core database. So in the core database, we've we've got two key concepts, the document model and distributed systems. So why the document model? It is the most natural way to store data. Right? It lets you store data in the way that people think about data. When any one of you think about your friends, your family, you tend to think of a person as a unit. You've got your likes, your dislikes, where you've lived, your phone numbers, everything about a person in one place. You tend not to decompose your friends into little pieces and separate them into different storage areas. That's generally considered creepy. Don't do it. You want to keep people together. Then you look at programming languages. They've evolved along the same way. You have things like a user class. A user class is going to keep all the information about a user together, so you can operate on a user in its entirety, just like in MongoDB. And of course, once you have your data in a document, you want a query language that naturally understands documents and is the easiest and most natural way to query those documents, and that's the MongoDB query language. And you want the schema to evolve as your application does and as your needs change. Distributed systems. Right? Distributed systems are all about giving you high availability. So if a machine breaks in the middle of the night, you don't have to worry about it. So you can scale out. So as your data needs and your throughput needs to go up, the system works for you, not against you. So you can have workload isolation and put different kinds of workloads in the same cluster so your business analysts and your transactional users don't stomp on each other and cause problems. And so you can put different data in the same cluster spread around the world so you can solve regulatory issues and keep data close to users so everyone around the world has a good experience no matter what. So we're going to talk about 3 ways we're improving MongoDB 4.2. First in transactions, then in high availability, and then in the query language. MongoDB 4.0, our release from last year, supported transactions in a replica set. Replica set transactions, first and foremost, were familiar. The syntax and semantics are very similar to transactions in any other traditional database you've ever used. They're conversational. You start a transaction, you do some reads, you do some writes, you commit, you abort, exactly like you'd expect. And they're fast. We didn't slow down 4.0 to make it support transactions. It actually got faster. And if you use transactions, they're quite fast as well. So first, a quick reminder. This is what the replica set transaction syntax looks like in 4.0. Start a transaction, you do some stuff, you commit. Very simple. In 4.2, we're adding distributed transactions. Transactions across a sharded cluster. So first, let's talk about the syntax and semantics of replica set transactions. So here's what it is in a replica set. Now let's look at the distributed case. Absolutely identical. No change. Transactions work exactly the same way. A replica set, sharded cluster. You start developing your laptop. The same transactional code will work on any size cluster. So the great thing about doing this in MongoDB is that you don't have to know how this works. But for those curious, let's take a quick look at what's actually happening. So here we've got a very simple MongoDB cluster. We've got a client, we've got our MongoS router, and we've got 2 shards. So the client's going to start a transaction. It's going to issue an update. That update's going to happen to go to shard 1. Shard 1 is now going to be in charge of that transaction. We're going to issue another update. That's going to go to shard 0. Now the client's going to say commit. It's fine. The coordinator is going to say prepare, get ready. All the shards are going to be, we're ready, let's go. The coordinator says commit, we're done, client's happy. Very simple, very clean. It only cost us between $30 and $50 million to build. Just because we have transactions doesn't mean you should model your data in Mongo like any other relational database. So here's an e-commerce order entry from a relational database. We've got our order table, we've got our line items table, and they're linked. You could do the same thing in MongoDB. You could have an orders collection and a line items collection, and you can use a transaction to insert into both and manage it that way. Please don't do this. It's the wrong way to do it. You need to still take advantage of the document model in MongoDB. Right? The order should be modeled like this. You've got an order document with some key attributes and an array of line items for everything you've purchased in that order. So what's changing in 4.2? First, transactions are now distributed. No matter how sharded your cluster is, it just works. In 4.0, there was a 16 megabyte limit on transactions. That limit is now lifted, and now you can do arbitrarily large transactions. You can also now change the value of a shard key. So previously, if you tried to change the value of a shard key, MongoDB wouldn't let you, because that might move a document from one shard to the other. Now, if you change the value of a shard key, behind the scenes, we're automatically going to create a transaction and transactionally move that document from one shard to the other. You don't even know what's happening. And of course, you can do that same thing in a sharded cluster, so that you can actually change the value of a shard key, maybe a location field, and that will automatically move a document from Australia to New York. To show you how powerful and easy to use distributed transactions are, I'd like to invite one of the engineers who helped build it to the stage. Please welcome Isha.
And snakes and storms never broke my bones.
Thank you, Elliot. Hey everyone, I want to show you some of the enhancements we made to transactions in 4.2 in action. So we're going to talk about distributed transactions, large transactions, and changing a document's shard key. I have this cluster on Atlas. It has one shard in North America and one shard near Australia. And throughout the demo, I'm going to be using an example of an Instagram-like application. So I have a collection where every document has a user, who that user is following, and who's following them. The collection is sharded on the location field so that each user's document is located on the shard closest to where they live. I don't know if any of you recognized that walk-on music. That was Taylor Swift's new single that she just released a video for yesterday. So let's take a look at Taylor Swift's document. She has a lot of followers. She actually has 118 million Instagram followers, I checked. But I'm using a smaller data set so I can show you the shell output. But more to our interest, her document is located in the US. And you might know her friend, Lord, who's a New Zealander. So her document is located on the shard closer to Australia. And maybe Taylor Swift wants to start following her friend Lord. So we can model this with two updates, one to Taylor Swift's document to add Lord to her following array, and one to Lord's document to add Taylor Swift as a follower. We could run these updates one at a time, but wrapping them in a transaction gives us some extra guarantees. Specifically, either both of the updates will be applied or neither, and the updates will become visible in the same snapshot, so at the same time. And these are ACID transaction guarantees. OK, so we can run this. And as you might expect, now Taylor Swift is following Lord. But let me show you a little more about how we achieve these guarantees, even though these documents are separated by an unreliable network. As Elliot mentioned, one of the shards involved in the transaction will coordinate a two-phase commit. So in this case, I've connected to the shard that coordinated the commit for this transaction. And we can take a look at its op log. OK, so we see that first, the coordinator shard wrote down which shards participated in the transaction. It wrote down the updates that it itself had to apply with this, sorry, I'm scrolling too far, with this prepared true flag, which means it had acquired all of the locks and was ready to commit, but hadn't made the writes visible yet. And it told the other shard to do the same, write down your operations with a prepare flag. When it heard back OK, it wrote down the decision to commit and the timestamp at which the writes should become visible, and sent that info to the other shard. So I think that having the server handle this two-phase commit so that your data remains consistent, even if it's separated by a network, is a pretty powerful tool for developers working with distributed data. OK, so that was a distributed transaction. Now let's talk about large transactions. Say Taylor Swift decides to quit Instagram. So we can model this by removing Taylor Swift's document and removing her name from everybody who is following her and everyone who she's following. I might have gotten those backwards. The thing is, Taylor Swift has so many followers that this might result in more update operations than could fit in a single oplog entry. But that's OK, because in 4.2, we actually write the operations across multiple oplog entries and link the entries together in a chain. And when the transaction commits, all of the operations in the chain become visible together. So let me show you what that looks like. OK, this is one of the shards again. OK, so here you see the updates are spanning multiple oplog entries. And each oplog entry has a timestamp, as well as this prev op time field, which is a pointer to the previous entry in the chain. OK, so that's pretty cool. We can do transactions with an arbitrarily large number of operations. Finally, I want to talk about changing the value of a document's shard key. So this is not changing which field is the shard key, but just changing the value of that field in some document. OK, assume we have some user, Jane, who lives in Australia, and we're trying to load her data here in the US. So it takes a little while, 240 milliseconds. But what if Jane moves to the US? Well, we would want her data to move to be closer to her. Now we can do that by changing the location field. And notice that it uses the regular update syntax. There's no special syntax for changing a shard key. And underneath the hood, this is going to run a distributed transaction to delete her data from the Australia shard and insert it into the North America shard. And if we try to load her data now in the US, we see it takes 10 milliseconds rather than 240. I hope you will find this trio of transaction features useful, and enjoy the rest of your day. Back to you.
Thanks, Isha. Simple and powerful. Distributed transactions in 4.2. Same conversational syntax, fully ACID transactions, just like you've always wanted and have always expected. Read your own writes, right? Very simple developer experience, and exactly identical to replica set transactions. If you want to learn more, the product manager behind distributed transactions is giving a great talk this afternoon, so go listen to Ali's talk a little bit later. High availability. High availability should be table stakes for any database today, period. No one wants to wake up at 3 in the morning if a server crashes. Of course, in MongoDB, the main mechanism for high availability is replica sets. Right? So if one machine crashes, others take over. They've been in MongoDB for almost a decade, and we've been making continual progress on them every year to make them a little bit better. But high availability doesn't end at replica sets. It's also about the developer experience. What is the developer experience when there is a failure, when something does go wrong? How do you have to make your application handle that code? So MongoDB 4.0 added retriable writes. Retriable writes is a contract between the driver and the server that allows the driver to automatically, behind the scenes, retry a write operation, and the server will guarantee that that write operation happens once and only once, making it easier for developers to write applications that are always available. In 4.2, we're going further. In 4.2, we're adding retriable reads. So now we will also automatically, in the driver, retry reads after a network failure. So if there's an election, if there's a hardware failover during a web page load, there's some reads in the writes, the driver will automatically retry them so you don't have to worry about it, giving your users a better experience and making it easier for your developers to write bulletproof apps. Retriable writes has been so successful that we're making them and retriable reads the default in 4.2. We want using distributed systems in MongoDB to be easy and give you enough confidence that you can focus on building applications and not about making the system work. The MongoDB query language, the best way to query and work with your documents. So we're improving the query language in 3 really interesting ways in 4.2. First is around how you can update it, The next is how you can do analytics. And the third is around indexing. Updates. So you've always been able to update individual fields in a MongoDB document. You can set the value of any field. You can increment a counter. You can add something to an array. You can do multiple of them at the same time. Very flexible, very powerful. There's one thing you haven't been able to do before, though, and that is set the value of A to the value of B plus C. And we think it's time you could do that. So now you can do things like this. You can go to your orders collection and set the value of total to the sum of subtotal and tax. It's a simple example, but what else can you do? So we've taken the entire aggregation expression language and put it directly in update. So now anything you can do in an aggregation expression, you can do directly in an update statement. So here's a more complicated example. We've got an order. It's got line items. We want to compute the subtotal for our order. So we're going to go through everything in the line items, multiply the unit cost by how many the person has purchased, add it all together, and set that to subtotal. Right? Previously, you'd have to take that document out of MongoDB, figure out what the right value is, put it back, and hope no one else changed it while you were doing it. Now, in a single operation, you can do this incredibly cleanly. More and more developers want to do analytics off of their real-time data. Having a separate system for doing analytics, for looking at your data, is a headache. Separate system, separate synchronization, your data is less real-time. That doesn't work very well. One of the challenges, however, is that for some queries, the data is so large that running a query is going to take a long time. Let's take a look at a simple example. Let's imagine I've got an e-commerce store, and on all of my admin pages inside of my sort of internal app, I want to have a little graph that shows me how much I've sold every day for the last 60 days. That's fine. I can write an aggregation query to compute that, but maybe it takes a minute to run. I don't want to run a minute query for every single page load. So what do? I can cache it. Now I probably have like 3 problems. So I don't want to do that. So what I probably want to do is have some sort of view inside my database. So what a lot of people do is they run an aggregation query in Mongo and use $out to store that inside of Mongo. And then they can just query that for their sort of real-time graphs. But that's a little bit stale. And so you could update it more frequently, but that could be expensive. So one of the things we're doing in 4.2 is letting you incrementally update that view as new data comes in. So we've added a new aggregation stage called $merge that lets you run an aggregation on a subset of your data, on the new data, in this case only your new orders, and merge the result of that with your old data. So you can run this all the time, every 5 minutes, and have a view of your data that is almost real-time very cheaply. To learn more about $merge and all the great things you can do with aggregation, you should go and listen to Asi's talk later this afternoon. No matter how great a query language is, if you can't index it, it's never going to be efficient. So indexing in MongoDB has always been pretty powerful, but there's been one thing that's always been a little off. So now let's take a look at our product catalog. So here we've got a t-shirt. It's got some core attributes. It's got a name and a price. And it's got other attributes, color and size. Now in the same product catalog, let's say we have milk. So milk has different attributes. It's got a sell-by date. It's got some unit size stuff around gallons. Now let's say I want to do a query. And that query is I want to find all things that are blue. Hopefully I'm not finding any blue milk, but you never know. This query works just fine. It works great. If I want to index it, I can do that as well. I can create an index on attributes.color. But what if I want to query on other attributes? I'd have to create an index on every single thing. Any given product in a product catalog typically has around 30 attributes. The total number of possible attributes across all products in a product catalog, 30,000. You can't make 30,000 indexes on a collection. Don't even try. So if you're using MongoDB 4.0 or older, what do? You've got to use this workaround. So instead of having a nice attribute subdocument, you turn it into an array of tuples, key value pairs. You index it on this tuple-y thing, and it works. You can query it. You can do all the things. But this is just ugly. Right? This is a kludge. And the whole point of the document model is that we want you to store the data exactly the way you want. We want you to store it like this and have it just work. So in MongoDB 4.2, we've added a new feature called wildcard indexes. With a wildcard index, you can create an index on attributes.star, and any query you do on attributes.anything just works. To show you just how powerful wildcard indexes are, I'd like to invite to the stage the one, the only, Asya.
Thank you, Elliot. Good morning. Schema and index design are in fact most challenging when you don't know upfront what your schema is going to be and all of the attributes. Previously, we've recommended a pattern where you store your dynamic attribute in an array of key value pairs. The key is the attribute name, the value is the value, and then you create a compound index on the combination. Let me show you an example in a very simple product catalog. This is Compass, and here's a document that has an array, very long array with lots of different attributes in it. For example, here we have price, $7.99. If we want to query for that price, we must use $match, don't forget that, so that the same element matches both the price and the value. And I have an index already created on the compound fields key and value. If we run an explain on this, you can see that the query is very fast. And in fact, it's using this index. So we could query by any attribute, and we get an indexed query, but it doesn't feel very natural, does it? Instead, what we would like to do is to store documents kind of the way we think of them, which is you have an attribute that's name, then the name, price, and then the price. Now the query also becomes a lot more natural looking because you're just querying for attribute price, $7.99. But it was not easy to index this. In fact, you couldn't index every possible attribute that might ever in the future show up in your product catalog. MongoDB 4.2 gives you ability to create a wildcard index, which will index everything in a subdocument or even in your entire document. Right here, you can see I have an index on adder.$**, and that means that everything under the adder subdocument will be indexed. If we now run the exact same query, you can see that the index is in fact being used. But let me show you a more complex example. I took a data set that's available in Atlas for weather data. And weather data is, there's the schema. I think it's being sent by some sensor somewhere, maybe like an Internet of Things type thing. And you can see there's a lot of different fields. A lot of them have embedded subdocuments, visibility, wind. Here, I'm going to pretend I'm a surfer, and I'm interested in height of waves. And waves, you could see, I want to query where the height is between 35 and 40 feet high, which is pretty high. We're going to run an explain, and you can see there's no index available for this query, so we have to examine all 10,000 documents to get the result. So let's build a wildcard index right here in Compass. I'm going to create an index. I'm going to call it wildcard, just because that's descriptive. And now I'm just going to specify $**, which says index every field. And under options, you can see that there's a wildcard projection option. This is because I could specify that I want to exclude some of the fields from the index, or you can specify that you only want it created on some of the fields. We get an error here. Let me see if possibly the index was already created. This is, of course, a very early version. In fact, the index is there, and here it is. So we're going to go back here and run the explain again. Look at this. Let's actually do this in the tab that I switched to check that the index was there. Very early version of support for a brand new feature. Query used the following index. It used the wildcard index right here, and it was able to execute, of course, nearly instantaneously. So whether your documents are unpredictable schema because you're maybe mining social media data or your customers are providing their own attributes, or because you're collecting Internet of Things data, MongoDB 4.2 wildcard indexes allow you to use the natural document format, and your users will still get to use efficient queries. Thank you. Back to you, Elliot.
Everything we're doing in the query language is all about continuing to deliver on the promise of the document model. We want the document model to work for developers so developers can build great apps and not worry about storing their data. So we've talked about some of the great features in MongoDB 4.2, but there's a lot we haven't got to cover this morning. There's a lot of other great features in 4.2. You can download the beta today. It's available in Atlas as of today as well if you want to go start trying with it, and it'll be coming pretty soon. Everything we're doing in MongoDB 4.2 is to make sure that MongoDB is the best database for modern applications for any use case on any platform. A modern application using a modern database deserves a great modern operational experience. And to me, that comes down to 5 key things. First, availability. Things break, your users shouldn't know. You want to upgrade, should happen rolling, your users shouldn't know. It should always be available. You want great monitoring and alerting. So if something does go wrong, you can figure out why, and you can detect problems before they happen. Backup in case things go haywire. Self-service, so your users, your developers don't have to create tickets just to make database changes. All driven through great APIs, so you can have a single pane of glass controlling everything. We have 2 ways of doing that at MongoDB. One is MongoDB Ops Manager. The other is MongoDB Atlas. MongoDB Ops Manager is the best way to run MongoDB on-premise. One of the great things about Ops Manager is the backup feature. And backup has 2 great characteristics that I really like. The first is point-in-time restore. So you can restore not to a random snapshot, but to 4:33 p.m. The second is so that you can query data in snapshot form. Because very often you don't actually want to do a full restore of all your data. You just want to go look at 2 documents that some random user deleted by accident. There's been some problems with Ops Manager backup, though. There's been a lot of moving pieces. And moving pieces are hard to manage, hard to scale, hard to reason about. And of course, those pieces need hardware, making it more expensive to run. So in MongoDB 4.2, we're completely changing the backup architecture. So here's what the architecture in 4.0 looks like. And now here it is in 4.2. Much simpler. The key change is that we've removed the concept of heads entirely, removing that entire architectural component using WiredTiger snapshots instead of that, making it much easier to manage, much easier to scale, and much easier to reason about. The product manager behind Backup, Ben, is giving a great talk on it this afternoon if you want to learn more. If you are on-premise, your users, your developers, are probably asking for a public cloud-like experience in a private cloud. And your job is to deliver that kind of an experience with a little bit more privacy. The way you're probably doing that is through Kubernetes. Right? Kubernetes is becoming the default way people think about private cloud. Last year, we released the beta version of our Kubernetes integration with MongoDB Ops Manager. This year, we've added a lot of new features. It handles a lot more complex cluster topologies. It handles scaling up VMs. It handles sharding for you automatically. It integrates so it handles self-healing if machines break. And it's got full security out of the box. In addition, as of today, it is GA. So you can go use that GA in production right now. It also works with any flavor of Kubernetes. Whether you're using open source Kubernetes, we're also OpenShift certified. And we're also excited to announce that we are also now certified on the Pivotal Container Service. To learn more about Kubernetes and MongoDB working together, Jason and Andre are giving a talk this afternoon. MongoDB Atlas. Fully managed, hosted database as a service for MongoDB. Dave talked earlier about how our users love MongoDB Atlas. Why? It is the best way to run MongoDB in the public cloud. But of course, no matter how important the database is to your application, it's never the only thing. And more people want to have a single pane of glass to manage your full application. The two most popular ways people are doing that today are with Terraform and Kubernetes through the Open Server Broker API. We are currently building integrations for both of these, and they're both becoming soon. Auto-scaling is another really important feature that ensures that you have high availability so the system can handle load without you having to do anything. Last year, we released auto-scaling for disk size. So as your data volume increased, you would automatically increase the size of your disk drives. This year, we're going further. This year, we're doing VM scaling. So we are constantly going to be monitoring your CPU. And if your CPU needs to go up, we will automatically increase the size of your VM. Of course, if your CPU load goes down for a while, we will decrease it as well, so you're not paying for hardware you don't need. This is in a private beta right now. If you want to try it out, let us know, and you can get in the beta. Security in any hosted database service is paramount. MongoDB Atlas has some of the best security features out there. Encryption at rest, everything over the wire is always encrypted, every MongoDB best practice built in. We also have a number of certifications. We have SOC 2 Type 2. We will sign BAAs for HIPAA workloads. As of a couple weeks ago, we're also ISO 27001 certified, right, the internationally strongest security certification you can get. PCI compliance coming soon as well. But there is some data that is so sensitive, no matter how many certifications we have, you're still nervous about putting it in a database as a service. Let's take a look at an example. Here's a document. It's got a social security number in it. No MongoDB employee would let me put their social security number on the screen. I tried. None of them would do it. Why? It's private. You don't want it leaked. You don't want anyone to see it. Storing this document in Atlas might be a little scary. Storing this document in Atlas, not scary at all. You want to encrypt the key fields. You can, of course, in your application, encrypt any fields you want. But it's kind of a pain. So we decided to make it really, really easy. So in 4.2, we've got a new feature called field-level encryption. So first, field-level encryption happens entirely client-side. It's built into every single MongoDB driver. The driver will encrypt the data before it leaves the driver, and it will only be decrypted when it gets back to the driver. This all happens completely transparently to the developers. The MongoDB API doesn't change. You configure this when you configure the connection, and then when you insert a document using the exact same API, behind the scenes, the driver is going to encrypt the fields you want encrypted, send it to the database, and it's only decrypted when it comes back to the driver. The database never, ever sees the clear text. The most powerful part of this, though, is how you choose the encryption key. There's a lot of options here. You can have an encryption key per collection, an encryption key per field. Or my favorite, you can have an encryption key per user. You can say, I want to use one encryption key for every user for every collection. So all of Elliot's data across all my collections is encrypted using the same key. Why is that so powerful? So now Elliot's got one key, everyone else has a different key. Well, everyone has their own key. Now let's say I want to delete Elliot. You're like, get rid of this guy. What do? Deleting Elliot's documents, it's annoying, but you could do it. But if there's a lot of data, maybe it'll take a while. But what about all your backups? Are you going to delete Elliot's data from every one of your backups? It sounds like a nightmare. You're all thinking right now, how would I do that? You can't. What you can do is delete Elliot's encryption key. And now all the data you have stored about Elliot, gone. You've basically wiped me off the planet, exactly like you want to do. Jeez. MongoDB Atlas is the most secure way to store data in the public cloud, and field-level encryption is just making it better. We've got 2 great talks on encryption and field-level encryption, one by our product security lead, Ken, this afternoon about how this all works, and another, Kevin, who actually was one of the engineers who helped build field-level encryption also this afternoon. Your data problems, of course, don't end at the database layer. And we said earlier that my goal is to make working with data easy for developers wherever they are, whatever the problem may be. This morning, we first started talking about full-text search and how we want to make full-text search really easy. We've got a lot of other stuff we want to do to make working with data outside the core database really easy as well. So the first thing we're going to talk about this morning in this area is MongoDB charts. MongoDB charts, or the product we released in beta previously, is the most intuitive way to build charts and dashboards off data sitting in MongoDB. It's fully interactive. You drag and drop fields. You build charts. Your users can actually interact with them, zoom in, pan, et cetera. And it's fully document aware. It understands arrays naturally. It understands what you might want to do with different kinds of data. And it works really nicely. This is what the chart builder looks like. You can drag fields, move things around, lots of different chart types. You can take those charts, put them into really beautiful dashboards. And one of the new features in MongoDB charts is that you can actually build charts and build dashboards in MongoDB charts, but then embed them in your own application. So you can build the dashboard once. You embed it in the application. And not only can you embed a generic chart, you can embed a chart where the data gets personalized for every user logging in. So Elliot logs in and sees Elliot's dashboard. To show you just how easy it is to build charts, build dashboards, and embed them in your applications, I'd like to invite the product manager behind MongoDB charts. Please welcome Tom.
Thanks, Elliot. So hi, I'm Tom Hollander, Product Manager for Charts. Now, two of the things I love are data visualization and great food. So today, I'm going to be using data visualization to help me decide where I should be going on my ultimate foodie vacation in the United States. And the best way of visualizing data that's stored in MongoDB is using MongoDB charts. So let me show you why. So I've already loaded into my Atlas cluster a whole bunch of information about restaurants and restaurant reviews. And then I've gone and activated MongoDB charts within my Atlas project. So let's get charting. So this here is the chart builder. And I am going to select my restaurants reviews collection. Now notice how charts is showing me all the fields in the collection, calling out the different data types in use, as well as calling out where there are nested documents and also nested arrays within that particular collection. Now chart supports a range of common chart types. But to get started, let's build a simple column chart that shows us the average restaurant reviews rating for each state. So doing that is simply a matter of dragging the state field into the x-axis, and I'll take my review rating field and put that into the y-axis. Now, notice that because the review rating comes from an array, and that's because every restaurant might have multiple reviews, Charts is asking, how would I like to handle this array data? So there are a number of options here, but in this case, we want to calculate the mean or average score for, across all the different reviews. And furthermore, we want to calculate the average score for all the restaurants across an entire state. So let's give this chart a title, Review Score by State. And in just a few seconds, we have our first chart. But this probably isn't the best way of visualizing this particular data. So this is all about geography. So wouldn't it be better if I could use a geospatial chart type to visualize that? So let me go and choose a different chart type. So I'm going to choose the geospatial category, and then I'll use what's called a choropleth, which is a fancy way of saying that we're going to be shading in the states based on their restaurant review scores. So let me just center this and zoom this a little bit. And suddenly we have, I think, a much nicer chart that gives us a really visual idea through both the shading and also the tooltips of where we might be wanting to go on this particular foodie trip. So let me save this to the dashboard, and I'll rearrange it a bit to make a bit more use of the screen real estate. So you can see here there's a bunch of places we could go. But it looks like California is a bit of an outlier with some great restaurants. So that's going to be probably pretty high up on my list of places to go. But it's also a pretty big state, so I'd like to narrow it down a little bit. So let's build another chart to help with that. Now, my next chart's going to be similar to my first one, so I'm going to use the duplicate chart option. But this time, rather than just coloring in the states, I'm going to use a heat map to actually show me where in the state I should be going. Now, this particular collection has GeoJSON data that has the latitude and longitude of every restaurant stored. So I can simply drag those coordinates into the appropriate field, and we can see here the hotspots of restaurants around the whole state. But remember, we've already decided, or the whole country. But remember, we've already decided that we are interested for now in California. So let's use the Filters tab to very quickly filter just to show data from California. So let me zoom in to get a bit of a better look, and we'll give my chart a better title, review score by area in California. Save that chart to our dashboard too, and resize it. And you can see that there's a cluster of some pretty good restaurants around the Bay Area, so that might be where I might be going first. So great, I built my dashboard with a couple of lovely geospatial charts, and I'd like to share it with some other people who also love great food. So I could use this access button to share this with other people who are members of my Atlas project. So that's great, and that might be sort of 2 or 3 of my colleagues, but suppose I want to share this information a little bit more broadly. So this is where embedding comes in. So with embedding, I can use this wonderful authoring experience and then make this chart available in any web-based application. So let me choose the embed chart option. If this were sensitive data, I could use verified signature to make sure that this chart could only be seen by authorized people. But since this data is not sensitive, for now I'll be using the unauthenticated option. So I can simply turn on unauthenticated access, leave it on, copy the embed code, and I could paste that into any application. So today I've got a WordPress blog, could be anything, but let me go and choose the custom HTML widget, paste in that, and press the preview button. And we should see in just a couple of seconds, we have my chart embedded in that blog. Now, this is not a picture. This is actually a live chart where I can zoom and pan. And if new restaurants or reviews were added to the collection, that would be instantly reflected in this particular blog post. So I hope I've shown you today why MongoDB Charts is the best way of visualizing data stored in MongoDB, as well as embedding them in your own web applications. Back to you, Elliot.
So MongoDB Charts, the most intuitive, interactive way to build charts on your document database. So when is it available? So MongoDB Charts is GA today, both in Atlas and on-prem. So you can start building really great charts right now. It is the best way to visualize your document data. If you want to get more of Tom, you've got 2 chances, once this afternoon and again tomorrow morning. Real time is what every application wants to be. And in MongoDB, we've added a lot of great features over the years to make that possible. In 3.6, we added change streams, so you can write code to listen to changes in the database. Last year, we added triggers to Stitch, so you can, in your Stitch application, you can write serverless functions to respond to changes in the database. And this year, we've gone further. We just released a new feature in Atlas that brings the power of Stitch triggers directly into Atlas. So now in the Atlas UI, you can go and create serverless triggers, JavaScript functions, responding to changes inside your database. You can write a function that every time a document gets inserted into a certain collection, goes ahead and sends a text message. Or another one that every time you update a certain document in a collection, you change a materialized view. Or if you go ahead and delete a document, let's say the Elliot document again, you go and remove him from the rest of your systems. And maybe the way you do that is you put that message onto a Kafka stream. Right? Kafka is, of course, the most popular open source data streaming platform. So if you've wanted to use MongoDB and Kafka together before, a community member, Hans Peter, wrote a MongoDB sync for Kafka and MongoDB. He's done a great job with this. And we're very excited to announce that MongoDB is now taking responsibility for this. So first, we want to thank Hans Peter for spending a lot of his own time working on this over the years. He's here somewhere. And we are both going to be supporting this, and we are making it both a sync and a source for Kafka. It is in alpha today. It is verified gold by Confluent and also available in the Confluent Hub. Phones. You all have one. You all love it. you also all hate it. Regardless, my goal is to make working with data easy no matter where you are, so of course that includes your mobile phone. 2 months ago, we announced that we were acquiring Realm, the most popular database for working with data on your phone. So why are Realm and MongoDB such a good fit? MongoDB and Realm are both based on the same principles. Working with data should be very easy for developers, and developers want a document-like data model. So to talk to you about why Realm is such a great database for mobile developers and why they built Realm in the first place, I'd like to introduce you to the Realm co-founder, Alex.
Thank you, Elliot. We're super excited about joining the MongoDB family. It's really an exciting step for us. And I want to give you a quick introduction to why Realm's history, how it was built. So I actually used to work for Nokia. So I worked on these feature phones you all used with playing Snake and all that stuff. And I worked on how to make data small, fast, and efficient on these phones. And then the smartphones happened. We got the iPhone, we got the Android phones, all that happened. And we found out that there was really no good way to work with data on these phones. The only thing was there was old SQL database you put in there, and nobody wants to use SQL on a phone. It just doesn't fit the way you work. So there was all these ORMs built on top, like Apple had their own, there was tons of different ones, all incompatible for Android. And ORMs, which is like an object relational mapper, is just something that nobody likes. It's like this leaky abstraction. I mean, even when I go to SQL conferences and I speak, even they hate all their ORMs. It's just universal. It's just the most hated thing. And especially on mobile, where everything is objects. Everybody worked with objects. So we saw this opportunity to make a database that felt natural for developers, that was actually fit into the system. And we launched that, and it was a huge success. Actually, you're probably all having Realm on your phone right now, literally all of you, because we're everywhere. I mean, there's so many apps using Realm. And why do mobile developers love Realm? Well, it's actually very, very similar to MongoDB, which is why it was such a good fit. Because just like Elliot said, they looked at web developers and they saw that they usually use JSON and documents to work with data. We saw that on mobile, everybody was using objects, and there was no object database that existed. So we actually made one that worked the way they think, in objects. And it was deeply integrated with the language and the platform. So that was a whole new experience, and that was what really made people like this. And it feels like the obvious. It feels like you're not even using a database. But that is just the tip of the iceberg. You use objects like you would do anywhere in your language, but suddenly you got all these extras. You got observability. You can observe every object. You got performance. You got queries across them. You got concurrency, which is surprisingly important on mobile. And you got transactions, making it all safe. So that was a great experience. But the most important thing is that it removed tons and tons of boilerplate code. All this complexity you had to build before just goes away, and it just makes it much more natural to work with. So what's going to happen now that we're part of MongoDB? Well, first of all, Realm is going to stay Realm, but we're going to add lots of new stuff to it. So we're not becoming a JSON database, but one of the most requested features in Realm has been the ability to work with unstructured data. And we're going to add a lot of features to this, leveraging all the experience that Mongo had with this. So we're going to add new data types for working with unstructured data. We're going to add stuff like dictionaries, like sets, like the mixed any type, all the stuff that allows you to put in unstructured data like JSON directly into the database and work with it efficiently. On top of that, we're going to have stuff like cascading deletes, which makes it much easier to work with document-style data. We'll have inheritance that makes it even more object-oriented. And we're going to have much more advanced queries, again, leveraging a lot of the query engine in Mongo, the learnings there, to add analytical and transformational queries. And last of all, we're going to add a lot more platforms, which is something we've been wanting to do for a long time, but didn't have the resource to do before. So the future is really bright for Realm and Mongo together. But if this was all we're doing, this would just have been great. It would be amazing. I mean, these are all the things that our user community have been asking for a long, long time. But we're going to do so much more. And I'm going to hand it back to Elliot, who will then show you the cool roadmap we have ahead of us.
So first, I'm going to take a moment and congratulate myself on going up and down those stairs 6 times without falling. It's a small feat. It's a small things, though. If you want to hear more from Alex, you've got 2 chances. The secret sauce behind Realm this afternoon, and then a hands-on tutorial from the expert himself on how to actually build a Realm app. So where are we taking this combination now that Realm and MongoDB are working together? So first, I want to reiterate what Alex said. We are not going to break Realm. A lot of people have been concerned, are you going to break it? No. Realm is great, and we're going to take our expertise and our resources and make Realm better. First. Second, we are going to build a universal sync solution for mobile data to MongoDB. What does that mean? Let's take a look at some use cases. First, backup. Data in your applications on your phone should be backed up easily and cross-platform. Let me tell you a little story. Dave mentioned earlier that Mongo's doing pretty well, so I can finally afford an iPhone. So I recently upgraded from an Android phone to an iPhone. And I had a podcast app on my Android, and it was backing up somehow using some Android-specific thing, and no idea how it worked. So I downloaded the same app on my iPhone. So what happened? All my meta information, all the podcasts I was subscribed to, what I had listened to, where I was in each one, all gone. I'm starting my podcast life over again from scratch. It's pretty upsetting. Like years of data in there that's just gone now. So the first thing we want to do with Sync is making it backing up data from your mobile application to MongoDB Atlas incredibly easy on any platform. Next, synchronizing your data across multiple devices. I have an iPhone. I have an iPad. The data should be synchronized in real time automatically. If I'm working on both offline, conflicts should be resolved. Things should happen. When you get back online, it should just work. Third, every mobile app probably wants a web component as well. And when you're working on a mobile app with a web component, you should be working with all the same data, all in real time, all incredibly easily. I want to be able to have a web app using the same data that I have on my phone, whether it's on an iPhone or an iPad or an Android, and have it all just work. I've got a web app, iPhone, I update something on the iPhone, it's there on the web app immediately. And last, but certainly not least, is doing this all sharing data across friends. So I can use this, I can share some data, share some fields, give read-write access, read-only access, and all have it just work, all via sync. So I've got one solution for moving data around between my phones, my web apps, and everything else that I care about in my application. So what are the components? What does this actually look like? Well, from Realm, we get a couple of things. We get great mobile experience, we get the great Realm database, and we get a lot of great logic in sync. From MongoDB Stitch, our serverless platform, we get a few key core backend features. We get authentication and rules, our system for letting you log in via Google Auth or any OAuth provider. We get serverless functions, so you can handle real-time things on the back end in a serverless, easy-to-consume way. And we get integration with things like GitHub, so you can manage everything in one place and have it deployed automatically. And on the web, we get some great Stitch features as well. We get Query Anywhere, so you can run MongoDB database queries through this auth and rule system from anywhere, including your phone, including a web app. And we get static hosting, so you can deploy your full app in a very easy-to-use way. All of this combined will be the new MongoDB Realm coming out later. It will be the best way to build data-intensive applications anywhere. So we started this morning talking about ambition. We wanted to start off just right, not too much, not too little. And I think we've saved the best for last. So we've got one more cool thing we're going to show you today. Let's start with a problem that I believe a lot of people here have. And that is namely that you have an enormous amount of data. So much data that storing it in any transactional database isn't very efficient. Maybe it's not transactional data, it's just archive data or sensor data or IoT data, It's just a ton of data. So what do you do with it today? Well, you're probably storing it on something like S3. Why? Because S3 is about an order of magnitude cheaper than any transactional option. So you're storing an enormous amount of data on S3. What do you do with it? Well, now that it's there, how do you query it? How do you work with it? So you can do something and use some like streaming service-y thing, like that lets you write code against that data, but that's annoying. You've got to write code. It's hard to sort of go play with the data. You could use some SQL tool to go look at it, but then you've got lots of problems. You're using SQL again. You've got JSON data. You're probably going to define a schema, and you don't know what the schema is because it's just random data on S3, so how do you solve that problem? And what you really want to do is just be able to play with that data, query it, maybe in real time, maybe in batch, and experience and see what's going on, and turn that into actionable data that you can actually work with. So let's take a look at what this data actually looks like in real life. So over here, I've got an S3 bucket, and this S3 bucket has a few folders in it. One of them is restaurant data. This is the same reviews data that Tom was using a few minutes ago. So in this folder, we can see a bunch of files. I've got some JSON files. I've got some older CSV files. Some random developer put in an Avro file because they wanted to try it out, and now I've got to deal with this file in here. I've got some Parquet files, some compressed files. It's kind of a mess. All right, so I can go look at one of these. Take a look at it. It's a bunch of JSON data. It's a lot of data, so it's probably going to crash Chrome, so let's back out quickly. So what do I really want to do here? What I'd love to do is take this data and use the best query language for querying rich data and just be able to query the data as it sits here in S3. So to make that possible, we are introducing a brand new product today called MongoDB Atlas Data Lake. And we can query this data right now. So let's give it a try. So we're going to go over to Atlas. We've got a new data lake section over here. And we're going to configure a new data lake. We're going to go ahead and we're going to call it Fun Demo, if I can type. Next, we're going to put in our S3 bucket name right over here. Now we need to give Atlas access to this data. Right, read-only access, I'm going to create a role, and so fun role 1. And now I'm going to do something that I'm sometimes good at, sometimes terrible at, which is following instructions to the letter. But we're going to try it anyway. So we're just going to first create a role using all these commands. And now we're going to actually create this policy. OK, and we're done. OK, so now we need to test to make sure it actually worked. So we're going to put in the role that we created through the console and hope that it worked. Oh, it takes a second. OK, great. Now we have a data lake. What do we do with it? So first we connect to it. It's just a regular Mongo connection string. So I'm going to connect to it via the shell. And I don't want you to know my password. It's a really good password. Let's see what's in here. All right, nothing's here yet. So now we need to configure it. So I've got a configuration that I wrote before. Here it is. So there's two things you have to configure to use Data Lake. The first is the list of S3 buckets. You can have as many as you want. Each one of them has a name, what region it's in, and a prefix. So you can look at a subsection of the bucket or the entire bucket. Then you define your databases. And there's two ways to do that. The first is very explicitly. Here's a database, here's a collection, here are the files or the folders I want you to look at. Or there's the automagical way. Create a collection for every folder or every kind of file in this directory and just tell me what's here. So that's what we're going to do here. So we're going to just turn this on. Great. And now if we do look at the database, we've got a restaurants database. All right. Let's use that. Now if we look at collections, we've got a reviews collection. So we can look at a document. Now this is exactly the same document that's in my S3 bucket. Not moving data around, not putting it into MongoDB. It's just streaming directly from S3 through Data Lake back to the shell. So now let's do a more complicated thing. let's count the number of restaurants per country. So there's a field called location.country. And we're going to count, and we're just going to add 1 for each one. And then we have our result. That's simple. So I've done an aggregation against all the files in that S3 bucket in a matter of seconds. So now I've got a more complicated query that I wrote before. What this is going to do is look at everything in that folder, compute the average rating per restaurant, sort, and then show me the top 5. Right, this way, if I want to figure out where to go in the world for dinner tonight and just get on a plane and go, I can do it. Turns out, it's easier for me to run this query against all this data in S3 than it is for me to pronounce the name of this restaurant. Osteria Francescana. I think I did OK. So that's it. MongoDB Atlas Data Lake. All your data in S3 available through the Mongo query language in a matter of minutes. So how does this work? One, it's completely serverless. You don't set up servers. You don't configure anything. You don't pay for infrastructure. You only pay for what you use. You're only paying for data transferred from S3 to our compute, from our compute back to you. That's it. You query the data in S3. Not moving it. You're not moving your data from your S3 buckets to our data lake. You're not paying for storage. You're not doubling up on storage costs. We query the data exactly where it is. We support a lot of file formats: JSON, BSON, CSV, TSV, Avro, Parquet, more coming soon. We support compressed files or not compressed files. It doesn't matter. The standard Mongo query language, the standard MongoDB API, so every MongoDB tool, every shell, every driver just works. So when can you start using this? So it's first going to be available on AWS, and the public beta is available today. So you can actually start querying your S3 data in about 5 minutes. It's that simple. Well, support for Azure and Google is coming later. And if you want to go under the hood and see how it works, Craig, one of the staff engineers who's been working on this, is giving a talk today and tomorrow about how it works. There are some products that when you see them, it really changes the way you view the world. When I first tried Data Lake and first got to actually query data in S3 that easily, my mind was blown, and I think yours will be too. So this morning, we've talked about a number of ways we're making it easier to work with data for developers everywhere. In the core database, we've talked about distributed transactions, retriable reads and writes, expressive updates, on-demand materialized views, and wildcard indexes. To make MongoDB work great in a modern operations environment, we've talked about headless backups, the Kubernetes operator that's now GA, auto-scaling in Atlas, ISO compliance, and field-level encryption. And in trying to make it easier to work with data outside the core database, we've talked about Atlas full-text search, MongoDB charts, Atlas triggers, the new Kafka connector, MongoDB Realm, and Atlas Data Lake. I've said this a few times this morning, but my goal is to make working with data easy for developers everywhere. I think we've done a number of things this morning that are going to make everyone here's lives a little bit easier when you're working with data. I really hope you get to try out all these new features and products. Come talk to me about all your data problems. Learn a lot today and tomorrow, and have an absolutely great time at MongoDB World. Thanks for coming.
Woo!